Alright, let's just jump right in. We are surrounded by all these invisible forces, right? But I'd argue that none of them are more essential to our modern world than magnetism. It's literally the thing that builds our technology, it protects our entire planet, and it all starts with a really simple question. I mean, really think about that for a second. It's this tiny little needle floating around in a case, and yet it somehow reliably points to one specific spot on the globe. There are no wires, no batteries, nothing. It just knows. Well, this isn't magic. It's physics. And it's the perfect way to start understanding this unseen architect of our world. So yeah, the answer to that compass question, and honestly, so much more, lies in this force that we can't see or touch or hear. But its effects are absolutely everywhere. At its very core, magnetism is just this fundamental push and pull between certain objects. It's a non-contact force, which means a magnet can affect something without ever actually touching it. You felt this yourself, right? Playing with magnets on the fridge, that little jump as they get close to the metal, that's the force in action. So how does that force actually travel from the magnet to the object? It travels through something we call a magnetic field. A really great way to picture this is to think of it like an invisible bubble of influence all around the magnet. Anything that comes inside that bubble can feel the magnet's push or pull. Now here's the cool part. This invisible force isn't just random chaos. Oh no. It follows a very strict and predictable set of rules. And once you know these rules, you can predict exactly how any two magnets are going to behave. And rule number one is this. No matter how big or small a magnet is, every single one has two different ends or poles. A north pole and a south pole. And get this, even if you snap a magnet right in half, you don't get one piece that's north and one that's south. Nope. You just get two brand new smaller magnets, and each one has its own north and south pole. Which brings us to the big one, the one rule to rule them all. Opposites attract and likes repel. It's that simple. Bring a north pole near a south pole and they just snap together. But try to bring two north poles together, you can actually feel them pushing each other apart. It's this one simple, elegant law that's behind everything. You know what's really cool though? Magnetism isn't always a permanent thing. For some materials, it's a property that we can actually turn on and turn off. Let me show you how. You can actually try this one at home. If you take a regular piece of iron, like a paper clip, and stroke it over and over with a strong magnet, you're basically telling all the tiny magnetic parts inside the metal to line up. The key is you have to keep stroking in the exact same direction. Do that enough times, and voila, you've just made your own temporary magnet. And just like you can create order to make a magnet, you can also create chaos to destroy one. If you hit it up, or whack it with a hammer, or just drop it a bunch of times, all those actions scramble those neatly lined up parts, and the material just loses its magnetic mojo. Okay, so we know what magnetism is. We know how it works. But why does any of this matter? Well, it turns out this invisible force is pretty much the secret ingredient in almost all of our modern technology. Seriously, think about it. The music you listen to, that's from magnets vibrating inside your speakers or headphones. All the data on your computer, stored in tiny little magnetic bits on a hard drive. Even the seal on your fridge, the strip on your credit card, the motor in an electric car, it's all magnet. And it gets even more personal. I mean, the very device you might be watching this on right now, your smartphone, it contains over 20 tiny magnets. They're the reason your speaker works and your microphone and even that little vibration you feel in your pocket. So the big takeaway here is clear, and it's not an exaggeration at all. From the giant power plants that generate our electricity all the way down to the tiniest parts in our phones, our entire technological world is built on our ability to control this one invisible force. But we save the most important magnet for last. Because the biggest magnet in your life isn't in your phone, is not in your car, is the one you're standing on right this second. That's right, our entire planet is a magnet. A huge, gigantic magnet with a north pole and a south pole. And it generates this immense magnetic field that stretches way out into space. And this field isn't just some fun fact, it's our shield. All of that churning molten iron deep in the Earth's core creates this magnetic field that protects us, batting away the most harmful radiation that's constantly streaming from the sun. Honestly, without it, life on Earth probably wouldn't even be possible. And that brings us full circle right back to our compass. A compass doesn't know which way is north. It feels it. That little magnetized needle is just a tiny magnet that's lining itself up with our planet's massive magnetic field lines, kind of like a tiny iron filing snapping into place around a giant bar magnet. The big magnet is telling the little magnet exactly which way to point. So we've seen that magnetism is a fundamental rule of physics. It's the engine of all of our technology, and it's the shield that protects our entire planet. Which leaves us with one last kind of scary thought. If this invisible force is doing so much for us, what would happen if it were just gone?